Good afternoon, students. So yesterday we had started up with RC transients, right? So in RC transients, we saw about the RC transients charging and discharging. Okay, the only difference here is in RC transients charging, the expression is I of t is equal to E by R into E power minus t by RC. This is the final expression what we had got. But for discharging, the expression will be the same, but with a negative sign. Okay, that is the only difference. So now we will go about to the problem. First problem, find how long it takes after the key is closed before the total current from the supply reaches 25 milliamps. When voltage is 10 volts, R1 is 500, R2 is 700 and capacitance is 100 microfarad. Okay, so the circuit is given. The circuit consists of two resistors R1 and R2 and a capacitance. Okay, and a voltage source is also given. The value for voltage source is also given to be 10 volts. Okay, now we are going to find out the current, total current. Okay, the total current also has been given. We are going to find out the I of t value. Okay, now before going into that, we will first consider this circuit. Now check here, find how long it takes after the key is closed. So you have to find out the time period, right? So for finding out the time period, we will find out I of t and then only we'll proceed. Now, as two branches are there in the circuit, okay, let me assume, 1 minute. Let me assume the current through R1 is I1 and the current through R2 is I2. Okay, so as it is going to be a parallel branch, we have I1 and I2. Now, the total current has been given. The total current is the one which is flowing in the circuit here, right? So now calculate I1. I2 I cannot calculate because I2 consists of the capacitance, right? So I1 I will calculate. I1 is equal to V by R1. Okay. Now what is V by R1? Voltage, you know, voltage 10 volts has been given here in the problem. Okay. 1 minute. Voltage is 10 volts and resistance is 500. So 10 by 500, I1 is equal to 20 milliamps. Okay. Now this is going to be a parallel circuit. So I can write the expression I is equal to I1 plus I2. What is I? I is going to be the total current. I is equal to the total current which is going to flow in the circuit. Okay. And that will be equal to I1 plus I2. Now we had got the value for I1, right? So we will find out I2 because I2 directly you cannot find out as a capacitance is connected there. Okay. So I2 is equal to I minus I1. I is given to be 25 and I1 we had calculated as 20. So we are getting the value as I2 is equal to 5 milliamps. Okay. Now they have told the capacitor is going to charge because the see what has been told in the question is this switch T is closed and if this switch is closed at T is equal to 0, the capacitance will start charging. Okay. Now we will take the expression of the charging, okay, and we will derive the value for T from that. So I2 is equal to, this is the expression what we had derived in charging. Okay. So I2 is equal to I2, capital I2 into E power minus T by R2C. Okay. Now what is this I2? Now we have to define this I2. Okay. I2 is of course with respect to voltage we have to write. So I2 is equal to V by R2. Now voltage is given, resistance is given. So directly we can substitute and get the values. So in this expression, I2 we are substituting from here. Okay. I2 is what? 5 milliamps. So 5 milliamps means we are going to take that as 5 into 5 by 1000. Okay. Milliamps is 10 per minus. Voltage is given in the question. So V is equal to 10. R2 is also given. We are just substituting that value 700 into E power minus T. T only we are going to find out. Okay. This is going to be the instant of time. T by R2 into C. R2 is given 700. Capacitance value is also given 100 microfarad. Okay. Microfarad 10 power minus 6. So we are going to substitute all this value, rearrange the equation and find out the value of T. So this is going to be 5 into 10 power minus 3. Okay. Is equal to 10 by 700 e power, after simplification it is e power minus t divided by 0.07. Okay, now I have to remove this exponential term, right? To remove the exponential term I have to take the natural logarithm. So ln of 0.35, okay, is equal to ln of e power minus t by 0.07. I hope you understood how you're getting 0.35 after simplification of 5 into 10 power minus 3 into 700 this by 10. Okay, after this simplification we are getting it as ln of 0.35. So use your calculators. Okay, after using your calculator and simplifying this, you can get the value as minus 1.05 is equal to minus t by 0.07, or rearranging the equation, the answer is t is equal to 0.0735 seconds. Okay, they had asked to find out the time, so we are just substituting in the charging equation, rearranging, taking natural logarithm and finding out the value of t. Okay, so this is the first problem. We will check out with the second problem. Second problem, for the circuit shown below. So they have given a circuit. This is a simple RC circuit, resistance 1 ohms, capacitance 5 farad and 10 volts is the supply. The initial charge in the capacitor is 25 microfarad. So they have given the initial charge. What is the initial charge? The capacitor has been connected in some other circuit and it has been charging for some point of time. So they had given the initial charge as 25 microfarad. The switch is closed at t is equal to 0. Find I of t. So I of t is going to be the response what you're going to find out. Okay, but now this problem is for the second one, discharging. Okay, because they had given the initial charge. So based on that, we have to substitute the value and we have to find out. Now let Q naught be the initial charge on the capacitor. So the problem will be following the derivation, right? So the derivation, whatever we have done, the same steps will be followed here. Okay, so let Q naught is equal to the initial charge on the capacitor. Now let me calculate V naught value. How to calculate V naught? V naught is equal to Q naught by C. Q naught is given, 25 microfarad has been given. Okay, so 25 microfarad divided by capacitance. So divided by capacitance, you will get the value. You will get the value as 5 into 10 power minus 6 volts. Okay. Now going to the circuit. Now you have to find I of t. Okay, I of t has to be found out. So for that, what I will do, I will write the equation. Now this is going to be a simple circuit based on Kirchhoff's voltage law. You will be writing the equation. Now see here, IR plus 1 by C integral of, okay, IR plus 1 by C integral of minus infinity to t I dt is equal to E. E is going to be the voltage which is connected there. Okay, so this interval minus infinity to t is going to be splitted. We will write it as minus infinity to 0 and 0 to t, because one portion we have the value 5 into 10 power minus 6. The other one we do not have. We are going to check out. We are going to derive that value. Okay, so now we are going to substitute that value here. Okay, 1 minute. Now here we are substituting I plus 5 into 10 power minus 6. Okay, 5 into 10 power minus 6 is the initial voltage what we had calculated. V naught is equal to Q naught by C. Okay, that value is substituted here, plus 1 by C integral of 0 to t I dt is equal to 10. We are substituting the resistance and voltage, all the values. Okay, so this will be simplified like this. This 5 into 10 power minus 6, I am taking it on the other side. Okay, so this will be reduced to 9.99. So I plus 1 by 5 integral of 0 to t I dt is equal to 9.99. Okay, now what is the other thing? Now integral of I dt is there. I have to find out the t value. So what I will do, the same procedure. Okay, the same procedure we will take. first Laplace transform on both the sides. So I of s, when I take for I, Laplace, it is I of s plus 1 by 5 into integral means you will have 1 by s. Okay. So integral of 0 to t I dt will be I of s by s is equal to 9.99 by s. Okay. This is going to be a constant. 9.99 is a constant. So for a constant, when you take Laplace, it will be 9.99 divided by s. Okay. Now, rearrange the terms. I of s is been pulled out commonly. So you will have I of s into 1 plus 1 by 5s is equal to 9.99 by s, or rearranging you will have I of s is equal to 9.99 divided by s plus 0.2. Okay. Now this is of the form 1 by s plus a. So it is easy for you to take inverse Laplace, right? So this will be I of t is equal to 9.99 into e power minus 0.2t. Okay, so 1 by s plus a, when you take Laplace inverse, it will be e power minus at. Okay, this is how you move about it. Now, if the circuit, for this circuit, the circuit is similar to as that of the derived circuit in the problem, right? So you can directly substitute the formulas also. Directly you can take the last formula and substitute, you will get the same answer. Okay. But you have to know this procedure, because if it is given if the circuit is given in a different format, see, like this, the circuit is of this format, we have not done this in the derivation. So you have to definitely derive that out. Okay, so you have to know the procedure. What is the procedure? Step one, we will be writing based on Kirchhoff's voltage law. We will write the equation. Then we will take a Laplace transform. We will solve the a and b values by partial fractions. Then finally, you will take an inverse Laplace transform to find out the value of I of t. Okay. So this is the procedure. So RL transients, RC transients, both means the same, both will be similar. Okay, there instead of inductance, you have a capacitance there, and you will be having a initial charge in the capacitance. There you will be having a current. Okay, so next we will move on to the RLC transients. In the RLC transients, as the name tells, you will have all the elements connected in series. Okay, so just check this circuit. Just check this circuit. So if you see here, the resistance, inductance and capacitance all are connected in series with a voltage source, and in between we have a switch, okay, switch S, which is going to be closed at t is equal to 0. Clear? Now we are going to apply KVL and write a equation for this circuit. So for resistance, I will write it as Ri, okay. For inductance, we will write it as L di by dt. For capacitance, we will write the integral 1 by c integral of minus infinity t into I dt is equal to E. E is the voltage source which is going to be connected. Clear? So next, we are going to solve this and we are going to find the value. Okay. Now we know, now see here, Ri plus L di by dt, right? Now for capacitance, this interval is going to be splitted. So first we will come to the capacitance. The interval of minus infinity to t is going to be splitted into minus infinity and 0 and t. Okay. So because we are going to tell that some initial charge would have been present in the capacitance. Okay. So this is going to be the initial charge minus infinity to 0 integral of I dt. Okay, so this is going to be, we are going to assume initially this value as 0, c is equal to 0. So what happens? This term is completely, it is going to be neglected as it is going to be 0. Now taking Laplace, next we are coming to the next one. Next one, when we are going to take Laplace, the inductance will have an initial condition. Okay, now see here, for L di by dt, we will come from the first. Now for this equation, I'm going to take a Laplace. For Ri, when I take a Laplace, it will be R into I of s. Okay. Plus L into, for di by dt, it will be S into I of s minus I of 0 plus. Okay. What is I of 0 plus? 1 second. I of 0 plus is going to be the initial current. Okay. Plus 1 by c integral of 0 to t I dt. So 0 to t I dt will be, when you take a Laplace, it will be 1 by s. Okay. And you have a c here. So I of S by CS. Please go through the equation along with me, otherwise you will not understand. Okay, it will look similar, but it will confuse you. Okay, is equal to voltage. Voltage is E here. So this is going to be a constant. So constant means we are going to take a Laplace transform. So that will be E by S. Okay. Now assume that I of 0 plus is going to be 0. We are assuming I of 0 plus is equal to 0 just for simplification. Okay, if a circuit is given and initial charges are there, of course, definitely you have to take that into consideration. Okay, so now this is also going to be 0. So you will have, now the terms are reduced, R plus LS plus 1 by CS into I of S, okay, is equal to E by S. So we had got the final one, right? Now here we are going to rearrange the equation. I of S is equal to E by S into R plus LS plus 1 by SC. Okay. Or this will be, now simplify this much more. This will be E by S square L plus RS plus 1 by C. Okay. Now again, I have to have the coefficient of L should be removed. So what I will do, I will pull out the L here, okay, outside. So this will be S square plus R by LS plus 1 by LC. So this will be in the format of quadratic equation. Okay, now what is the quadratic equation here? S square plus RS by L plus 1 by LC is equal to 0. So now applying the formula, B square minus 4AC is equal to 0. Okay, or S is equal to minus B plus or minus square root of B square minus 4AC by 2A. Apply that because we are going to solve the quadratic equation. Okay, so this will be, what will be B here? What will be A value? Are you all listening, ma? What is A value in this quadratic equation? The chat box is enabled. I wanted you to give me the answer. What is A value in this quadratic equation? What is A value in the quadratic equation considered? We just have the quadratic equation ax square plus bx plus c is equal to 0. So apply that. Tell me A value in this equation. A value is 1. Okay. What is B value? B value? B value is R by L. What is C value? Only 2 persons giving me response out of 210. C value is 1 by LC, right? So it has been posted in the formula now. We are just substituted in the formula minus B plus or minus, okay, square root of B square minus 4AC by 2A. As A is equal to 1, you will not have a denominator. The 2 value has been brought up. Okay, just by rearranging, if you rearrange, you will get it like this. Now what I'm doing for simplification, I'm going to assume this as alpha. Okay, if you see here, minus R by 2L, I'm going to assume it as alpha. And R by 2L the whole square minus 1 by LC, square root of the entire term is going to be beta. So I'm assuming the second term as beta. So I can now write it as S is equal to alpha plus or minus beta, right? RLC will be somewhat different as that of the RL and RC. Okay. So what we do here, we had assumed 2 values alpha and beta. Okay. So I am writing S is equal to alpha plus or minus beta. Okay. Now, if the roots are going to be alpha plus or minus beta, then I can write it as S minus alpha plus beta or S minus alpha minus beta, right? I'm going to assume this as the first root. Please listen, alpha plus beta is the first root, and I will take some other color. Alpha minus beta as the second root. Okay, so this is the first root and this is the second root. 2 roots, S minus alpha plus beta and S minus alpha minus beta. Okay, now if these two are going to be the roots, then the equation can be written like this. I of s is equal to E by L into S minus alpha plus beta and S minus alpha minus beta, because we are considering these are the two roots. You understand this? We are considering, say, if you have so much of confusion, put this as S minus A and this as S minus B. Okay, then it will be clear. Now here we will assume three cases now. Till this it is clear. Anything has to be repeated? I'll open the chat box. You tell me if anything has to be repeated. I'll repeat, or else I'll proceed with the next one. Till this it is clear. Can I proceed? Till this it is clear, ma? Any doubts here? The chat box is open. I wanted you to post it. See, okay, I will explain again before proceeding. See here, we are starting up with the RLC transients. RLC transients, the resistance, inductance and capacitance are connected in series across a voltage source E. Okay. In between, you have a switch S, which is going to be closed at an instant of t is equal to 0. Now, for this circuit, we are going to apply Kirchhoff's voltage law and we are going to write the equation. So, when a current of I flows through the circuit, Ri plus L di by dt plus 1 by C integral of minus infinity into t I dt is equal to E. Okay. Now, for capacitance, the initial charges, we are assuming it to be 0. C is equal to 0. So, you will not have this term because as it is going to be 0, this term will be neglected. Next, what you do, we go in for a Laplace transformation. When I write for a Laplace transform, you will have a, when you write the Laplace transform only, you will have the initial condition for inductance. Otherwise, you will not have it. Please remember that. Okay. So taking Laplace transform on both the sides, what happens? R I of s plus Ls into I of s minus I of 0 plus is equal plus I of s by C is equal to E by S. Okay. Now assume that we are assuming again for the inductance, the initial current is 0. That's what I told you. For inductance, always current. For capacitance, always it is the voltage. Okay. Initial voltage is assumed to be 0 in capacitance, and in inductance, initial current is assumed to be 0. Okay. Now, R plus Ls plus 1 by Cs into I of s. That is, we are just rearranging the terms and pulling out I of s outside. This is equal to E by S. Okay. So I of s is equal to E by S into R plus Ls plus 1 by Cs. Now I'm rearranging this such a way that I'm getting a quadratic equation. Okay. Now in the quadratic equation, you know how to solve a quadratic equation. We are going to have b square minus b plus or minus square root of b square minus 4ac by 2a. Using this formula, you are going to solve it out. Now, when I solve out, I will be getting s is equal to minus r by 2l. 1 minute. Minus r by 2l plus or minus square root of r by 2l the whole square minus 1 by lc. Okay. Now, what I'm going to do, as the expression is bigger, okay, only for convenience, we are going to assume some variables. Okay. Now, this minus r by 2l is going to be assumed as alpha. Okay. So, this is going to be assumed as alpha, and this r by 2l, the square root of r by 2l, the whole square minus 1 by lc is going to be assumed as beta. So the equation will be reduced to s is equal to alpha plus or minus beta. Okay. So this will be, this can be, now we had got, this is a quadratic equation. It consists of two roots. One is, first root is alpha plus beta, second root is alpha minus beta. So I can write it as S minus alpha plus beta and S minus alpha minus beta. Okay. Now we are getting the equation, just substituting here. I of S is equal to E by L into S minus alpha plus beta and S minus alpha minus beta. Okay. Now we have here three cases. Okay. The first case, case 1, what we are going to deal is if R by 2L the whole square is greater than 1 by LC. Okay. Now what is the expression for beta? We have this value as beta. Okay. So we are going to consider R by 2L the whole square is greater than 1 by LC. So what does it mean actually? 1 minute. So if R by 2L the whole square is greater, it means that the roots are going to be real and distinct. Okay. So the roots are real and distinct means I will be having K1 and K2 as the constants. Okay. I'm going to take any constant. In some books it is given as A and B. Some books we are going to have some constants. We have taken it as K1 and K2. That's all. Okay, so K1 by S minus alpha plus beta and K2 by S minus alpha minus beta. So these are the two roots, and the roots we know it is going to be real and distinct because we have taken the case 1, R by 2L the whole square is equal to R by 2L the whole square is greater than 1 by LC. Clear? Now, this is I of S value. So to find out I of t value, we are going to take an inverse Laplace transform. Okay. So this is of the form 1 by S minus A. So 1 by S minus A means you will be taking it as e power at. Right. So this constant will be retained, K1 will be retained, and 1 by S minus A will be taken as e power alpha plus beta into t. Okay, so e power at, a we are assuming here as alpha plus beta. Same way the second one, K2 into e power at. Okay, always remember 1 by S minus A means it will be e power at. If it is 1 by S plus A, then it will be e power minus at. Okay, just the opposite. Now alpha, e power alpha t is common in both. So what I will do, e power alpha t, I will pull it out constantly. And this can be reduced into K1 into e power beta t plus K2 into e power minus beta into t. Okay. The current is said to be overdamped. Overdamped means the damping is very higher and it will not come to a rest at all. It will take a longer time to come to rest. Okay. That's why we call it as overdamped, and the response will be like this. This is the response. Okay, response is nothing but I of t. Response is nothing but a graph between I of t and time. I of t is going to be the current with respect to time. Okay, so this will be, the waveform will be increasing. If you take some values for t and plot it out, you will get a graph like this. Okay, this is for case 1. Next, we will proceed for case 2. In case 2, if the discriminant is 0. So what do you mean by the discriminant 0? Discriminant 0 means R by 2L the whole square is equal to 1 by LC. Okay, so this is equal means what does it mean? The beta value is going to be 0. So if the beta value is 0, what happens? Only the alpha value is there. So I will call the roots are real and equal. Okay, so now there will be a square in the root. So we will call it as I of S is equal to K1 by S minus alpha the whole square plus K2 by S minus alpha. Okay, so two roots only. You will not have any roots based on beta because the beta term is going to be 0. Okay. Now taking inverse Laplace, I of t is equal to K1 into e power alpha t plus, you see here we have a square term. So we have a t term here. So you will write it as K1 e power alpha t into t plus K2 into e power alpha t. Okay. Or I of t is equal to e power alpha t into K1 t plus K2. Okay. And you call the solution is critically damped. Critically damped is, it will be equal to 1. Damping ratio will be equal to 1. Okay, that's what you call it as critically damped. So first one is over damped, next critically damped. The third one what we are dealing is, the discriminant is negative. So negative means negative means you will have an imaginary term. Okay, so the roots are going to be complex conjugate. So what does it mean? R by 2L the whole square is less than 1 by LC. So what does it mean? The negative term is more than the positive term. So you will definitely have a negative sign there, right? So we will call it as, so negative sign means you will have a, when you take a square root, it will be of j term, minus j or plus j, or you will have a square root of minus 1. So you will have a j term. So the roots should be complex conjugate. Okay. So the roots now we write it as alpha plus j beta. Okay, alpha plus j beta and alpha minus j beta. Okay. So IF is equal to K1 by S minus A and K2 by S minus A. Now A I am writing it first for S plus j beta and the next one for alpha minus j beta. So now taking inverse Laplace, it will be I of t will be equal to K1 into e power alpha plus j beta into t plus K2 into e power alpha minus j beta into t. These are just the illustration only. You have to just understand. Okay. And the problems will be based on these derivations. Okay. Now, e power alpha t is going to be common. So I have pulled out e power alpha t commonly. This into K1 into e power j beta into t plus K2 into e power minus j beta t. Okay. So the above expression, to be very simple, we are just putting it as a cos beta t plus b sin beta t. Okay. Or you can stop with this. This will also do. No issues that you have to write the last statement. Okay. Clear? This is about the RLC transients, and here the solution shows that the current is oscillatory. Oscillatory is, it will be oscillating between the positive and negative, and the oscillations die at a short period of time. Okay, it will settle down at t is equal to 0. Right? So for RLC transients, we had discussed 3 cases. Case 1, R by 2L the whole square is greater than 1 by LC. Case 2, R by 2L the whole square is equal to 1 by LC. Case 3, R by 2L the whole square is less than 1 by LC. So it means that it is going to be a complex conjugate. Okay. You had understood? Right. We will follow it with a problem based on RLC transients. Okay. Now check here. See, RLC transients are very, very important as compared with RL and RC. Okay. Just check out this problem. A series RLC circuit as R is equal to 50 ohms, L is equal to 0.2 Henry, and capacitance is 50 microfarad. Constant voltage of 100 volts is impressed on the circuit at t is equal to 0. Find the expression for the transient current assuming initially released conditions. Okay. Now, the resistance value, inductance value, capacitance value, and the voltage value is given. Now, I do not know the circuit follows which case. We have 3 cases, right? Over damped, critically damped, and oscillatory. Right? Now, I have to calculate first R by 2L and 1 by LC value. And according to the value of these expressions, I will decide in which case the problem falls. Okay. Now check out here. We are following here. One second. Find out R by 2L the whole square value. R by 2L resistance is 50 by 2 into L, 2 into 0.2, the whole square. So this will be 15625. Okay, after calculation. 1 by LC, 1 by 0.2 into 50 into 10 power minus 6. So this is going to be 10 power 5. So from the values, from the numerical values, I can tell that 1 by LC is going to be higher. Okay, so our 1 by LC value is higher as that of R by 2L the whole square. Okay, so the current is going to be underdamped. Clear? 1 minute. Right? Now find out alpha value and beta value. We know alpha and betas, right, by the formula, right? So alpha is equal to minus R by 2L, whatever we had got there, okay? And beta value. So alpha and beta value, find it out. After that, we are going to now put it in the equation, substitute in the equation. Now see here, alpha value, we had got it as minus 125, okay? Minus 125. And beta value is 290.5. So both these values we had got, okay? Now, we are going to substitute in the equation. I of S is equal to E divided by L into S minus alpha plus beta into S minus alpha minus beta. E value is given in the problem. It is going to be 100. Okay, L is 0.2. S minus alpha we had got it here as 125. So we'll put it as 125 and beta is going to be 290.5. Alpha is minus 125. Okay. So substituting all the values of alpha and beta. Okay. Now we had got this equation the same way you are going to do. After getting the equation, you are going to apply partial fractions, find out the value for K1 and K2. Okay. After that, substitute the value for K1 and K2, take inverse Laplace transform, you will find out the value, final answer. Okay. So this 500 divided by S plus 125 minus J 290.5 into S plus 125 plus J 290.5 is splitted out into two terms, K1 and K2 with two constants, K1 and K2. Okay. Now cross multiplying, we will have the equation as 500 is equal to 500 is equal to K1 into S plus 125 plus J 290.5 plus K2 into S plus 125 minus J 290.5. Okay. Now we are going to substitute the opposite term such that one term will be made as 0. Okay. So now put S is equal to minus 125 plus J 290.5 such that it becomes 0. Okay. So by solving like this, you will find out the value for K1. Okay. K1 is equal to 500 divided by J 581. Okay. Or K1 value is 1 by J is what? Minus J. Okay. And numerical value 500 by 581, you will have it as 0.86. Okay. So now K1 value is obtained. K1 is equal to minus J 0.86. Now put the other value for S such that you will find K2 value. Okay. Now K2 value is also found out. K2 value is J into 0.86. Okay. Now after finding K1 and K2 value, you are going to substitute in the master equation there and you are going to take the inverse Laplace. Okay. So I of S is equal to minus J into 0.86 divided by S plus 125 minus J 290.5. Okay. And the other term will be positive. Now to find out I of t value, you are going to take the inverse Laplace transform. Okay. So when I take the inverse Laplace transform, this has to be, you have to rearrange the equation. Okay. Now check here, you are going to consider this full term as A. Okay. Then only you will have minus J 0.86 into e power minus at. Here a t has been left out. 1 minute. Here you will have a t. T has been left out. Okay. Plus J 0.86 into e power minus 125 minus J 290.5 into T. Okay. Or simplifying and pulling out e power minus 125 outside. Okay. This will be e power J 290.5 T minus e power minus J 290.5 into T. Okay. Here we have written the formula. Just check here. using this formula, e power j theta minus e power minus j theta by 2 is equal to sine theta. Okay, so this will be substituted here. So a power j theta minus e power minus j theta divided by 2. Okay, so this will be 2j sine 290.5. Okay, or simplifying this, I of t value will be 1.72t, okay, into e power minus 125t sine of 290.5 into g. Clear? So this is the final response of the current as per the problem. So this is the RLC. RLC, you have to check in which case it is falling and you have to solve the problem. Okay, any doubt, ma?
Last 2 minutes. You can extend the class even if you want.
Chat box is open. Any doubt you have? Or shall I proceed with the next problem? Is this clear? Became very tired as it is the last hour. The count of the students is going on decreasing. Right, we will complete one problem alone. Okay, last problem. Because with that problem, we will complete DC transients. Okay, now we'll proceed here. Next problem, series RLC circuit with R is equal to 300, L is equal to 1 Henry, capacitance 100 microfarad. As a constant of 50 volts applied to it. Find the value of current. After t seconds of applying the voltage, we get the following. Okay, now see here, they've not given the expression. That is, the circuit is not given. It has just been given RLC circuit. So the normal equation, whatever we write, the same thing we have written here. Okay, Ri plus L di dt, L di by dt plus 1 by c integral of I dt is equal to E. Okay, now we are going to substitute the values here. R value is 300, L value is going to be 1 Henry, capacitance is 100 microfarad. Okay, and voltage value is 50. So substitute all these values here. Okay, next we are going to take a Laplace transform. Laplace transform, see, we are going to, the initial conditions have not been given. So we will just take it as, we will just assume it as 0. Okay, now listen here. This is the same procedure as that of the previous problem. So I'll just speedily explain you. Okay. So 300 into I of s plus s into I of s minus I of 0 plus 10 by 10 power 4. 10 power 4 you had got from this. Okay, 100 into 10 power minus 6 will be 10 power minus 4. Taking to the numerator will be 10 power 4 into I of s by s is equal to 50 by s. Okay, now put I of s is equal to 0. So putting I of s is equal to 0, 1 minute. This term will be cancelled, right? This term will be 0. So you will have 300 I of s plus s into I of s plus 10 power 4 I of s by s is equal to 50 by s. Okay. Or rearrange the terms, I of s into 300 plus s plus 10 by 4 by s is equal to 50 by s. Okay. Now the next one. Now we are going to rearrange, as it is going to be a quadratic equation. Okay, we are going to apply the formula and we are going to find out the roots. Now before that, rearrange the equation. We will be getting this equation. 50 I of s is equal to 50 divided by 300s plus s square plus 10 power 4. Take up the problem, solve it out and check, then only you will get the answers properly. Okay. Now this 300 should be reduced. Then only I can substitute in this formula to find out the roots, right? So this 50 by this 300, I will pull it outside. Okay, 300, no need to find s square. If it has some coefficient, it has to be removed, right? So s square has no coefficient here, only 1. So you can directly factorize this. Okay, s square plus 300s plus 10 power 4. Factorize this. Okay, you will get this factorizing by using the formula. Okay, you will get the roots as minus 261.8 and minus 38.2. Okay. So you will have two expressions, K1, two constants we are taking, K1 and K2. K1 by S plus 261.8 plus K2 by S plus 38.2. Okay. Now two equations. So cross multiply, apply partial fractions, find out the value for K1 and K2. So this will be 50 is equal to K1 into S plus 38.2. Okay. Plus K2 into S plus 261.8. Now apply values for S, find out the value for K1. So K1 will be equal to minus 0.2236. And for K2 you have to find, so put value for S is equal to, put value for S as minus 38.2 and solve out, get the value for K2. K2 is 0.2236. I hope you are understanding. Any problem you tell me so that I will stop there. Okay. So K1, K2 values we had got it. We are substituting here in the final equation to get the value for I of S. So I of S is equal to 0.2236, okay, into minus 1 by S plus 216.8, just substituting all the values, okay, plus 1 by S plus 38.2. Clear? Now I of S has been obtained. I wanted I of T, so I will take inverse Laplace, okay. So this is directly of the format 1 by S plus A. So I will write it as e power minus 8. Okay, so 0.2236 e power minus 38.26 into T minus e power minus 261.8 into T. These terms have been rearranged. That's all. So only you are getting a negative sign here. Okay, this is I of T value. Now they have told it is required to find the maximum value of I of T, right? So maximum value of I of T, when will you get it? You have to differentiate the equation. You have to put it as di by dt is equal to 0. So differentiate this equation and equate it to 0. Okay, so differentiating this equation, you will get this is the equation what you're going to differentiate. Okay, minus 38.2 e power minus 38.2 into T plus 261.8 e power minus 261.8 into T is equal to 0. Clear? Now just rearranging, you will get this value of 6.853. Okay. Or to remove the exponential, we have an exponential here. To remove the exponential, I have to take a natural logarithm. Okay. So natural logarithm, if I take, T will be equal to 1.925 divided by 223.6. Or this T value will be equal to 8.6 into 10 power minus 3. Okay, this is the maximum value of current. T is equal to 8.6 into 10 power minus 3 seconds. That's what has been asked in the problem. T is equal to 8.6 into 10 power minus 3. Okay, any doubt you have? With this, we are completing the DC transients. Okay. IT Max only they had asked. So you can stop it out here. Or if you wanted to substitute, you can substitute and solve it out like this. Okay. Any doubts you have? So we had started up with transients. Transients is broadly classified into DC transients and AC transients. Okay, DC transients is applicable for circuits with DC supply, and AC transients is applicable for supply with AC voltage source. Okay. Now we had completed DC transients. In DC transients, we have RL transients, RC transients, and RLC transients. Right? So we had in RL again, you will have charging, discharging. RC, you have charging, discharging. RLC, you have three cases. Okay, case 1, case 2, and case 3. Now the same thing we will be doing it for AC transients also. In AC transients also, you will have RL, RC, and RLC. But in AC transients, what happens? The derivation is much more important rather than problem. But in DC transients, both are important. Okay. The derivation and the problem is important. In AC transient, the derivation is very, very important. Okay. Any doubt you have, ma? Any doubt you have? Just post it in the chat box or anything has to be repeated. Complete the angles. Zoom angles.
ஒரு நிமிஷம் ஒரு மணி வந்துச்சு ஓடுறேன்.
Any doubt you have, ma?
என்ன பண்ணுவேன்? நீங்க என்ன சைன் பண்றீங்க?
Right. Otherwise, we will continue in the tomorrow's class. We will start up with the AC transients in the next class. Okay. Thank you.
Control சிஸ்டம் வந்து தாங்க என்னன்னு